So in this video we are going to talk about file systems and basically what they do, why they are important to us as developers, and it's going to be a pretty introductory because we also talked about them in the previous unit, in the unit 4, but we are going to go deeper in this unit into file systems. So we want to make kind of a reminder or going deeper into some concepts of the file systems. So this video, what's going to be about? We're going to try to make you learn what's a file system, what are the basic concepts on file systems, basically only those two things. And it's going to be super basic concepts, okay? So file systems, what are they? The definition, one of the definitions of file systems is that it's a method and a data structure that the operating system uses to control how data is stored and retrieved. Okay, reading is easy, but what's that about? Okay, so that there it says method and data structure. Okay, so what's a data structure in this definition? It's the way that the file system, or that conceptually we do, the way to organize information so it can be read and written in a performant way. And what does that mean? That we cannot read and write randomly around the storage devices. We have to make some kind of order to those operations. So when you have to read after writing, or you have to look where you can write or where do you want to write, there's some type of organization, so you do it in the most performant way possible, okay, and the safest also. And the method, it says data structure, is a method and data structure. So the method is how those read and write operations are going to be performed. When, for instance, like queuing and scheduling, where physically how those read and write operations are going to be exposed as an API in another software methods. It's going to be exposed to the user, how the user can ask to write or read, or the user or other components in the operating system or other programs. So those tasks are the ones that the file system do. Okay, that's its function. But why do we need a file system? Why can't the programs or the components or anything just write and read anywhere? Okay, there are many reasons. Okay, but some of them that make each one of these makes impossible to work without a file system. So each one of them has to be fulfilled by the file system, so you can work with files storage, which is basically always. You will have to store information always. Each of them, it's super important. So why do we need file system? Because there are infinite different storage devices. Not infinite, but there are a lot of them. Hard disks, SSD disks, flash memories like USBs or pen drives, flash cards, tapes, I don't know, tons of them. Okay, diskettes, CDs, DVDs, and so more. Okay, so to make it possible to store information in a standardized way, we use file systems, so they organize the data for us, independently of the storage device that we are using. You can read and write from a flash memory card, or from a pen drive, or from a hard disk, and you do nothing. You don't know how that data is stored. Only the operating system has a file system to store that data into the memory. Okay, so that's one of the reasons. So that order is created by the file system. Okay. Another reason is that you have to abstract the way you store information in your program from the physical storage. What does that mean? That means that your program is not going to know in which specific part of the disk is going to write its information. It's going to say to the operating system, okay, I want to write this file in here, in this virtual structure. And the file system will say, okay, I will write it down. And when the program asks for it, it's going to retrieve it, okay? But the program doesn't know where in the physical storage that information is stored. Only the file system and the file management software knows that, okay? So that's another thing that you relieve that task from the program. You free the programs from doing that, okay? Another reason is standardizing the splitting sizes, basically the cluster sizes. We will talk about clusters later on in this video, but basically you cannot store files as a whole. Like you're not going to store 2 GB file like and in the hard drive and that's it. You're going to split it in tiny bits so you can put them in where they fit, basically. So that way you use more efficiently the space that you have. If you don't have a file system, that's an impossible task almost, okay? That's the task. That's one of the tasks of the file system, to store the information efficiently, splitting the files, for instance. And as I was saying, it's the same, organizing chunks of information performantly, putting those sizes, those tiny bits of files that each file is splitted. The file system organizes how they are going to be stored later, okay? So, and so many more, okay? So we are going to work on some of the basic concepts of the file systems. One of them is cluster, and the definition of cluster is the minimum in file systems, the minimum space unit that a storage device can use. Basically, it's like words in memory. In memory, you have the minimum space that the minimum memory space that can be used is 8 bits, 32 bits, 64 bits. In file system, exactly the same concept exists, and it's called cluster, and it's like the tiniest space where you can store something. It can be like this, it can be like this, or bigger, but it's the tiniest space, the smallest space, okay? So what does that mean in real life, okay? If you have a 256 bits file, you are going to, as I was saying before, you are going to split it in tiny bits so it fits anywhere, even if there are empty spaces or different spaces around the storage. So you are going to split it in different pieces, okay? So the cluster, what it defines is the size, the minimum size of those those bytes of files, okay? And for instance, if the cluster size is 32 bits, you are going to split this file into 8 parts, okay? Because 256 divided by 32, it's 8, okay? I did it on purpose, obviously. So you are going to have one part of the file somewhere in the storage, another part of the file somewhere in the storage, you don't know where, and the other 8 parts, okay? So basically that's super easy, okay? But what happens if the file is 200 bits and the cluster is exactly the same? That you're going to have a smaller final part of the file that it's going to leave an empty space. The red space is an empty space, okay? So the bigger that your cluster size it is, the more likely is that you have empty spaces in your bits, in your parts of the files that are being stored, okay? And the smaller the cluster size it is, the more parts you're going to have and the more parts you're going to look for. So you have to balance both things, and you can lose some space, but you will have more speed reading and writing, or if you have or you can lose speed writing and reading, but you're going to have more space available, okay? Usually, as we have a lot of space nowadays, usually you go with the speed, but not that much, not too much, okay? But That's important because of that. Okay, but the cluster concept, it's clear now, I expect. And partition, the definition of that's another basic concept in file system. A partition, it's a local region in storage. Okay, basically it's a virtual organization of the storage available, basically. Okay, and you split the storage available into sections which are abstract. It's not a physical. You don't take a knife and cut the hard disk into parts, and they are called partitions. It's virtual. Everything partitions are always virtual, and they are a way of organizing the space available in the storage. Okay. When they are created, they don't have a file system, and they are stored within the partition table, and that's stored also within the disk itself or the storage device. Okay, so what does that mean? That inside each disk or each storage device, there's going to be a table stored inside of it that is going to say, from this address of memory until here, this is going to be the partition number 1, or any name that it gives to it. From there to there, it's going to be the partition number 2, and from there to there, from this memory address until here, it's going to be the partition C. Okay, and that's stored within the disk. Okay, why do we use partitions? Okay, again, there are many reasons, but basically the first and most obvious reason is that way we can organize the information in different sections, so they have different purposes, for instance. And because of that, as you can organize information within different sections that they are independent, each one from the other in the virtually. Okay, you can avoid corruption. For instance, if one file gets corrupted inside a partition, and the whole partition, who knows why, gets corrupted because of that file, the other partitions probably won't get corrupted because only virtually they got broken, those files. Okay, so you can avoid corruption among each partition. Only one partition got corrupted, so okay, you don't care. Okay, so you didn't lose all of them. You didn't lose the whole storage device. Specific file systems can be mounted with different parameters. You can have different partitions with different file systems, which is also super important when we are going to talk about the features of file systems in another video. But you maybe will need a file system that has that allows you to have bigger files, or you need a file system that it's older to install on an older operating system that only works on top of that file system. So you can make partitions with different file systems to make many things with it. Okay. For instance, another thing, programs, that happens a lot with log files, for instance. When there are programs that are writing huge files and taking the whole space available until the full space is used, if you are using partitions, only that partitions is going to be used, because the program cannot get outside of that partition. Okay, so that way you protect yourself or protect your storage from wild programs that take the whole disk, the whole storage available. I didn't say it very well, but you get it. Okay. Also, another reason of using partitions, you can make a partition for the operating system and other partition for the file for the user files, so they don't get mixed and they don't interfere with each of with among them. So, for instance, maybe you can put operating system files in a partition that has a tiny space, but the operating system fits, and the user files more space, blah blah blah. Okay. Usually, this is the way that partitions look. Okay, you have a main partition, a secondary partition, and maybe a space for recovering the operating system from scratch. Okay. The blue partition would be main partition, the orange partition would be secondary, and the recover, okay? But again, this is a virtual thing, okay? It doesn't mean that the final storage, the physical storage device has those splittings, okay? Those parts. It's not going to be organized physically in those parts, okay? This is only virtual. This is important because, as I was saying, you can avoid corruption if, for instance, the orange partition gets corrupted. But if it is the physical device that it's going to be broken, you are going to lose everything. Okay. Another thing that it's important is that the partition table is stored within the disk. Okay. So if the partition table is broken, you are going to lose all the information basically, because you are not going to know. There are some ways to do it, but you're not going to know exactly from where to where the partition started and ended. So you're not going to know how the information was organized. So basically, you lose everything. Okay. So this is also important. A way to lose all the data is changing the partition table and changing it badly. Okay, I did it so many times. And I'm sure that you will do it so many times. So take care, really good care on modifying the partition table, okay? And the other two, or maybe the main concept on file systems is files, okay? What's a file? A file is any object that stores information that makes sense as a whole. What does that mean, okay? If I only said any object that stores information and that's it, it would mean from a song that it's stored in the hard disk, or a bit that says 1 or 0. Okay. What I wanted to mean with making sense as a whole is that maybe you have a whole song, or maybe you have a song split in many parts, but each part of the song, of the file, it's going to have its own meaning, because it's going to be part 1, part 2, part 3, part 4 of a whole concept, which is a song, okay, or the song file, okay. So that's what means that making sense as a whole. It's not any bit or part of anything. It has to make sense, okay. It's a concept more than it's going to be applied finally in the file system, but it's conceptually is that. And directories are files that organize another files referencing them, okay. That means that a directory basically is a specific kind of file that this is for instance, this is a directory, okay. And a directory, it's going to reference file 1, okay, or file 2, and so on. And maybe it's going to reference another directory, which is going to be D1, which will have more files inside of it, okay. So directories are specific types of files that reference another files, including another directories, okay. Make building structures that they are called inverted trees, because usually there's a root which is on the top, so that's why it's inverted tree. The root is on the top, so you go from the root to the bottom and you will get to what you need, to the file that you need, or the directory you need, okay. They are specific types of files. This is especially important especially obvious in Linux, because directories act super directly as files. In Windows or MacOS, for instance, it's not that plain that they are conceptually files, okay. You will see it later on when we make exercises about file management and stuff like that, okay. So to recapitulate, we learned about basic concepts about what's a file system, why they are important, what do they do, and we learned some of the basic concepts on file system: cluster, partition, file, and directory, okay.